So now I'd like to take just a little bit of time and talk about the sample data that we'll be working with. And as a reminder, this data is available to you online for your use and practice with R. So this data was collected for the SOLCAP project, or the Solanaceae Coordinated Agricultural Project, which is a USDA-funded grant program. And processing tomato fruit shape, color, and quality data was collected. And for the overall project, it was collected on a wider scope. But the data we're going to look at today, we have data from 2009 in one location with 2 reps. And we're looking at the color data. And we also have data from 2010 from one location, and there's 1 rep of this data. And it's also color data. And to obtain the data, the images were scanned and analyzed using Tomato Analyzer software. And the images on the right show you a little bit of the diversity that we had in the germplasm we were looking at. So you can see processing tomatoes with different shape, size, and color. So next, what kind of data does R need in order to make use of it, and in order for you to analyze your data? What format does it need to be in? So R works well with either tab delimited or CSV files. So if you start with an Excel file, like is posted online, you'll need to convert that into either a .txt or .csv format. And it's preferable to have your data in a flat format. As you can see here, we have our columns named line, rep, year, location, followed by our color parameters. By default, R likes missing data to be denoted as NA, and our headers should not have any spaces in the text, no commas, which applies mainly for CSV files, and they should begin with a letter as opposed to a number or other symbol. And just as an aside, our data from the SOLCAP project includes 143 tomato lines, and for each line in each rep, we have data for multiple fruit. So now that we have our data file, we'd like to import this into R. And so, just as an aside, all of the commands that we'll be discussing now, these are all available in a script file, and that's available to you posted online. And the name is script 2009 OH colorsample.txt. So we can either read our data into R as a CSV or text file. And the way that we do that, the general command would be read.csv, and in brackets, the name of our file, including the file extension, in quotation marks, followed by a comma, and header equals T. So header equals true. So our data has a header. And if you're working with a PC, you'll want to note the direction of the slashes here. And so what I have in this graphic is just the ways of reading in a data set for either a PC or a Mac as a CSV or as a text file. And what I've done is I've given that data set a name within R. And the data set will be referred to as a data frame within R. So our data frame is called OH color. And if you're interested in learning more about importing data into R, as this can be one of the most challenging steps of working with R, I would refer you to a file created by the R data or R development team, and that's available online. So we've imported our data into R. The next thing we want to do is check to make sure that everything actually worked properly and our data was imported correctly. And as a caution, the methods presented on this screen are really only when you're dealing with small data sets, because these have a long printout for each line of your data set. And so you could use either just type in the name of our object, which is OH_color, or we could type in print and OH_color or summary and OH_color. And those will all give us similar results. And I did not do that for this data set because it's rather large. So what I chose to do instead was to use what are called the head and tail commands. And so these allow us to see the first rows of our data and the header for the head command, or the last rows of our data including the header for the tail command. And you can see here an example of how I read in my data and how I looked at the first rows of our SOLCAP data here. So we've got essentially what it looked like in Excel. We've got our line, we've got our rep, year, location, followed by our color parameters. Another command for checking your data that I'm partial to is the structure command. And structure allows you to see the structure of your data set, including the total number of observations, which here is 2,539, the number of variables that you have, and how the variables are classified. And so R classifies our variables as either factors, like line and location are shown here, integers, as rep and location are shown here, or as numeric. So that goes for all of our color parameters. And this becomes important because we're actually going to want R to treat things like rep and year as factors, and it is by default brought them in as integers because they're numbers. So we're going to have to tell R that we wanted to read them as factors, and we'll get to that a little bit later in the presentation. And so to use the structure command, you would type in str followed by your object, which in this case is our data frame, called OH_color. So we now know that R has read in our data correctly. The next thing we would probably want to do is visualize our data. And as I mentioned, one of the most powerful things that you can do with R is to create graphics. And they can be anywhere from something very simple, as we've shown here, to much more complex. And you know, in this case, we're making just a basic histogram with our data. And so I've typed in HIST for histogram, the name of our object. And in this case, I want to look at one of my color parameters called parameter 1. So I've typed in the name of my overall data set, included a $, which is to note that we're dealing with a subset of our data, followed by the name of that subset. And so when we create a graphic in R, you will see that it actually comes up in a separate window. And so now we can see an example of building on that basic histogram. And so we've added color, we've labeled our axes, and we've given it a title, and we've also included an expected distribution in the form of a density plot. And so the code is included here for you to give you an idea of what you may be able to do with R. And to learn more about creating graphics in R, I would direct you to the R Graphics book by Mural in 2006.